Let's start. Let me just remind you the epsilon delta definition and start from there. So I think this is my page 3. So one more time, epsilon delta definition. Limit as x approaches a from either side of f of x is L. If that's the case, this is equivalent to going this way, and what I'm going to write here is equivalent to this as well. So this is the double equivalency symbol. For each and every, any epsilon positive, I will find a delta positive such that 0 less than x minus a less than delta, I'll explain and put it in words again if you want to, will ensure this. So let's take each symbol by itself so we know and understand these symbols. So this is for any or every. For any. There exists. Or I will find a delta positive such that. And this is a little bit longer, I'll say, when I pick x closer to a than delta. In other words, I will pick an x that is close enough to a, not a. That's why I have this. This means cannot pick x equal a. So this part right here, I cannot pick x to be a. That's the purpose of that, of greater than. You can say, but absolute value is always greater than 0. True. But the fact that it does not have equal symbol, it means that I cannot pick x to be a. So, for any epsilon greater than 0, I will find there exists a corresponding, I forgot to write. In other words, for any epsilon, I'll find a different delta. That's what it means. So for any epsilon positive, I will find there exists a corresponding delta positive such that every time I pick an x that is close to a, not a, but delta close, not outside of delta, okay, that will always imply the f of x, I'll put in parentheses, for that choice, of x will fall within epsilon of L. This mechanism happens only because the limit exists. So for every epsilon positive, there exists a delta positive such that every time I pick x close to a, not outside of delta, in other words, but not a, this x that I pick, its f of x, will be close to epsilon, close to L. How close? Epsilon close. Because this is the distance between f of x and L, and this is the distance between x and a. Okay, so let's pick a linear function. Can anyone, let's say x approaches 2, give me a linear function, any linear function you can think of, and let's find the limit. And let's prove it using the epsilon delta definition. So,
Just like 2x plus 5.
okay, 2x plus 5, when x approaches 2, the limit is perfect. This is equivalent to, for every epsilon positive, I will find delta positive such that x minus
9 or L. No, A. Sorry.
very good, less than How close is x to 2?
2.
I'm here, right? So I have x minus 2 less than
2. Delta.
good. This will always imply,
I thought you wanted a number. I got confused.
oh, sorry. This will always imply, which is
The 2x plus 9.
very good.
Minus 9. Less than epsilon.
Indeed, right? So let's look at the mechanism one more time. So this is our function, let's say. And I'm going to say that this is 2, and I'm going to say that this is 9. So for every epsilon, this is 9 plus epsilon, this here is 9 minus epsilon. So for any epsilon, I will find a corresponding delta. So either this, since that is the smallest,